So I'd like to introduce Dr. Jason Greenbaum. Again, Jay will be presenting IEDB Tools 3.0, the future of tools. So another really exciting behind the scenes look for you all to wrap us up for our second and final day. Thanks very much, Jay.
Thanks, Nina. Hello. And so I am really excited to be able to share this work with you on the future of tools. Apologies if I seem low energy. My kids are back at school now and they're bringing home new viruses each week. And I think they finally got me. All right. So I'm going to start by talking about the motivations and the vision behind the redesign. And then just really quickly get into the life cycle of a MHC1 prediction request. And then get to the fun stuff where we can do an actual live demo. And then we'll come back into the slides and do talk a little bit about integration of tools. So kind of building pipelines and finish up talking about some future plans and timeline. So why are we working on a redesign? There are many reasons. We're really proud of the tools that we have, but we think that the site, the navigation can use a lot of improvement. That's consistently been a point of feedback that we get from our users. There are no linkages between the current tools, so it's not easy to run one tool, send the output of that tool to another one as input. That's something that we want to deal with. There are inconsistencies among the tools in terms of things like allele nomenclatures and parameter names. And that's another issue we want to tackle. And just in general, the layout and the aesthetics are a bit outdated. And overall, we know we can do better. We can make the site more usable for everyone. So what is the vision? So we really completely rethought the whole user experience. And with the idea that when a user comes to the site, they should immediately feel at home and know what to do, know how to get their results. And also enable power users to perform complex workflows. So people that are really familiar with the system, that really know the tools that they want to use, they should be able to do everything through the website, or most of the things through the website. And we want to do that by emphasizing things like ease of navigation, simplicity of use, consistency between the tools, integration, so being able to take the output of one tool and send that to another tool and build up pipelines, and of course speed. So we want it to be fast. We want to be able to solve real world scale problems in a reasonable amount of time. And we want to do all this by drawing upon familiar paradigms, so things that we know well, things that are familiar to a lot of people, like REST APIs, JSON for data exchange format, and while not directly using Jupyter notebooks, just kind of drawing some inspiration from them. And so just real quick, I just wanted to go through what the life cycle of an MHC1 prediction request looks like on the new system. I'm not sure if you're familiar with the current system and the current APIs, but when this is supposed to be a user, when the user submits a request either through the website or through the API, that goes to our MHC1 endpoint. And instead of getting the prediction results back, what they're going to get now is a request ID. And the idea behind that is a lot of the predictions that we run can be time consuming, and it might be a while before they get a response. There might be web timeouts. By enabling or by sending an immediate request ID back, we can enable much longer, larger data sets to be run in the background. So they'll take that request ID, and then they'll need to pull this other endpoint called the results endpoint. And when they go there, they will get a response back that will give the status of the request, saying pending or running or failed, or hopefully the results. And when they do get the results, it should look something. Oh no, sorry, these aren't the results. This is the post. So this is the data that's sent to the MHC1 endpoint as a. It's formatted as JSON, so we have things like the input sequences, the alleles and lengths. And what's one of the new things about this new interface is that we are able to support multiple predictors in one call. So we're not only doing a single binding prediction, but we're calling two different binding methods here. We're calling processing and immunogenicity as well. And the response will look something like this. We'll have a results, a request ID, and then the URL that we need to go to poll for the results, as well as a bunch of associated information. And we'll also be able to provide errors in near real time. So when you get your request ID back, if there was something wrong with the input, we aim to provide clear errors that the user can take immediate action on. And when you then take the results URI and go to that URL, you should get something that looks like this. If the job is in queue, you'll see the status is queued, and then the results field is going to be empty. If there was some kind of error that happened in processing, you would get something that looks like this, that hopefully is a detailed error message. But what you really are hoping for is to get something that looks more like this, where the status is complete and you have your results formatted as JSON. So now I'm going to attempt to change my screen that I'm sharing, and we can do an actual live demo here. And I think it worked. Cool. So I'm going to start by looking at the API documentation. It sounds boring, but I think it's really cool. We're using a system called Swagger that will take all of the API endpoints that we have and present them to the user. We could provide documentation in here, and it'll even allow you to run requests right inside the documentation. So for instance, if we go down to our MHC1 post endpoint and open it up, we'll see a description of all of the parameters that can be used, what's required and what's optional. And then we'll see a description of what the response format looks like as well. And then, so not only do we see the description, but we can actually run stuff in here. So if we click on the try it out button, we're presented with this kind of skeleton parameter set that we just need to fill out to submit to get our prediction. And so I'm going to go ahead and paste a set of parameters in there that I previously put together. And so we see, again, we have our input sequence. Maybe I'll make it a little bit bigger. So we have our input sequence, the alleles that we want to predict for. So we're doing 2 alleles, we're doing 2 peptide lengths, and we're running a few binding predictions, we're running immunogenicity, and we're running processing as well. And if we just go ahead and click execute, that will now show us the command that got executed. So this is the actual post request. Excuse me. And then this is the response. And this is not a canned response. This is actually happening when I click execute. And so you see we get our results URI, so we can take that. And I'm just going to copy it and try to move my Zoom controls out of the way so I can paste that in another window. There we go. And so now we go to that results URI. It's pulling down the JSON results, and it's just taking a minute to format in the browser. There we go. And we can see our results already. So we have things like the column descriptions, and the actual peptide table is somewhere down below. Right, and so these results were ready. If they weren't ready, we would have seen something that said like pending. There's another way to get there. We can just take the ID, and then again in our documentation, go down to the results endpoint, click try it out, paste our ID in there, hit execute, and then we should get the same response back in a minute or two. There we go. So that's the back end. That's what the API endpoints look like. And now let's take a look at how we're tying that into the front end and what that's shaping up to look like. So this is the new IEDB AR, or a prototype of the new IEDB AR homepage, where we have kind of grouped tools into logical groups. So we have our T-cell prediction, class 1 and class 2 up top, B-cell prediction, and so on and so forth. And we kind of put this together with the idea that a user should have to give us the minimal number of inputs, the minimum amount of clicks in order to get to a result. And so we have this pre-populated with an example sequence where you could type your own sequence in here, and then there's an example allele. And then the idea is that we're going to take our best guess at the parameters, and then you would get more options on the next page. So when we go to run the tool, that immediately brings us to our new T-cell class 1 page. The sequence is pasted into this box. And as we came here, the prediction was actually running. So we can see if we scroll all the way down, the result is already pre-populated on this page. And so let me just back up a little bit and start back at the top of the page and just kind of go through some of the changes. So first of all, I think you'll see that the overall design and aesthetics are a lot cleaner than what our current interface looks like. Starting here, we have our input sequence box. Once you have the sequence uploaded here, you have the option now to download that in a variety of formats. So you could download it as JSON or FASTA or whatever the original format was that you pasted it in. You'll get immediate feedback about the sequences, how many are there, if there are some errors in parsing that sequence. I'm going to come back to this in a moment. Then you have controls for the peptide length. So by default, we set it to 9 and 10. And then there's the allele selector, and this is an autocomplete. So as you type in here, you'll get suggestions. And so now we have 2 alleles selected. And there's another alternative way of selecting alleles, which is just kind of going into this modal, where you can quickly select your 27 allele panel. We'll have other sets available as well. You can clear the selection and do other neat stuff like that. So let's leave the 201 there. And then if we scroll down a little bit further, we see that by default, we have the Mendes EL 4.1 selected as the prediction method, but we could choose any of the currently supported methods as well. And not only that, but we can add methods here. So we did Mendes EL, we could do consensus, we can add immunogenicity, we can add processing, and so on. And then we have the ability also to notify when predictions are complete. So if you click this button and then hit run, you'll get this pop-up that will ask for your email. So I'm going to go ahead and cancel that one and just kind of back up to the prediction parameters. So what we have here is a way for you to save the parameters that you've previously used. You can download the parameters as JSON and then re-upload them at a later time to reproduce your old results. And you can also do this with the URL. You could just copy this URL and share it with friends, colleagues, and they'll be taken to the same setup on the website. So let me just really quickly demo how we can upload parameters. I'm not sure what it's showing me right now, but I'm selecting a file from my computer. And now I've uploaded the sequence, and now we have 2 alleles and lengths 9 and 10. And now you see it's selected all of the different methods that were in my predefined set of parameters. And I'll go ahead and click run. This is the same prediction that we just ran on the API. So it returns really fast because we cache frequent requests as well. And now you can see this is what the table of results looks like. By default, it is sorted by the median binding percentile, and then these numbers indicate the rank of the sort. So this is it's sorted first by this, then by the CPAN-EL score, and so on and so forth. So we have the ability to multi-sort. We could do that by default. We could do that by clicking, by doing some control clicks. And there's other neat functionality built into this table, things like filtering and sorting. So we can sort A to Z, filter by numbers for numeric columns, filter by strings on string columns. And we get feedback up top that tells us, we had 5,000 results in total, and now we've whittled that down to 2,500 or so by filtering. Aside from filtering the rows, we also have this control here that will let you filter out columns. So maybe you don't want to see this entire table. It is rather large. Maybe some of these fields aren't that important to you. You can just go ahead and uncheck them, and just check a few and click display, and it should update pretty quickly. And now you can see the table is a bit more manageable with just the columns that we actually want displayed. You can go ahead and download this as a CSV. You can share this as a link or as a file. You can click on this and it will reset the table to the original state that was returned by the backend. So you get your original sort order and all of the columns displayed again. I think those are the major things I wanted to show you on this page. And if I could just really quickly show you a couple of the other tools that we're working on in parallel. This is the cluster tool. So if you're familiar with the cluster tool on the current website, I believe Alex demoed it either earlier today or yesterday. It's basically the same tool, but it's re-implemented without that kind of wizard interface. But now we have all of the controls on the same page, and you'll note that the design of this tool looks really similar to our T-cell tool. And so we're trying to carry that same, all those same design principles across all of the new tools to make things nice and consistent. And then just click run again here, and calculating, and we have our result. This tool is a little bit different because we also have some graphical output, which for now we've kind of just put down below the table. We're kind of working on where that fits in best. And then the third tool that's currently in development, Dan gave a nice overview of earlier, that's the pep match tool. That's not on our legacy website right now. This is only going to be implemented on our new website. And again, similar interface with the pre-populated example. We click run, and we get our table of results. And now I'm going to try to get back into my PowerPoint. Okay, and so we're working on these 3 tools because we want to start getting into building pipelines where we can run a tool and take the output of that tool, filter it a bit, send that filtered output to the next tool. So say we go from MHC1 binding to clustering, and then we take the clustering output and throw it into PetMatch. These are the kinds of workflows that we're trying to build and enable our users to build as well. And so, yeah, there's a lot of other planned features. We want to make packages available to users to access the APIs, provide different output formats, be able to share the data and pipelines, maintain a set of curated pipelines. And what we're currently working on is building out our high-performance cluster backend and queuing system so that we can really improve the performance and make the user experience pleasant. And so we hope to have that 3-step pipeline support very early next year, and our cluster backend and a beta release towards the excuse me, towards the middle of next year, with all of the remaining tools that are on the current site to follow, as well as any new tools that we develop. And I believe that's my last slide. Yeah, so this is the team that's been working hard at this for the past almost 2 years now. And thank you.
Excellent. Thank you so much, Jay, particularly because you are feeling under the weather. So you definitely deserve a great break after this. So thank you again. And I hope everyone enjoyed that little look behind the scenes of what we're working on. And again, this comes from user feedback, and we're always looking to improve on our existing resources. So if you were a few of the people that attended last year, you would have seen an earlier version and now an even newer version of the upgraded tools platform. So yeah, I hope you enjoyed that. But we're moving into our last little Q&A for the evening. So I'd like to invite Marcus back and then Jay. And I think we have a couple of questions that were submitted. So Marcus, did you want to take the first question?
Sure. Okay. To Marcus Mendes, why the antibody epitope predictions tool sometimes predict some peptides like epitopes with low length of as one amino acid biological, this length hardly ever it could be recognized as an epitope. Because the prediction is usually takes the amino acid and try to find the create a score based on the amino acid, for example, the physicochemical properties of the amino acid. So if that amino acid is quite exposed, for example, the prediction tool is gonna flag this epitope as like probably a binder, probably like a epitope. But of course, it doesn't make much sense if it's the only one. So this could be seen like a false positive, but it's because of the property of the amino acid, because that amino acid probably is like in a very exposed and like probably will trigger some be immunogenic. But since it's just only one, it's not immunogenic in the reality, but it's predicted as like a good one. I think I answer your question. So next one's for Jay.
Thanks. And yeah, so there's a question from Kate Skull that says, will the new version also use responsive web design so we can pop in a search from our mobile phones? Looks like it would. Also, the API looks super useful. Thanks about the API. Yeah, we're hoping it's going to be super useful. So responsive web design. So to be completely honest, I've heard that term before and I don't know exactly what it means. But I can tell you what we are using, and we are using, we're trying to be really careful about separating out our front end and our back end. So our back end is made up of Django API endpoints, and our front end is an Angular application. As far as mobile phones, we are not focusing on being able to support that as well. We're anticipating that most of our users are going to be on a desktop. So we're going for kind of a you know, the aspect ratios that we're looking at are meant for desktop consumption.
Excellent. A couple of great questions there. I'll give everyone maybe 30 more seconds to see if they would like to submit anything else while we still have Jay and Marcus here. But I did want to touch on while we wait, the design process that the team's been going through with the tools is really interesting and exciting and iterative. So we go through multiple steps of design, implement or develop, test, do some user testing, and it goes back through that loop every time. So we're building upon our designs, we're testing it with our team, with external users, with an expert committee that we have in the IEDB as well. So it's a really great model for us to design, test, and deliver in a cyclical approach. So yes, looking forward to releasing that to you all early next year. And I can see that we have no other questions that have been submitted. So with that, I will thank you, Marcus and Jay, for your wonderful presentations.